All right. Good afternoon, everyone. I'd like you all to please welcome Zac Hatfield-Dodds, who is the core developer of Hypothesis, PyTest, and Trio. And he will give us a talk about notes, groups, and stars, exceptional new features of Python 3.11. Yes, Python 3.11.
Thanks very much. Hello, everyone. Welcome. Thank you for coming. I'm going to try my best to give a great talk, and I hope you will accept it if I do badly. That's the worst pun of the talk, I promise. And it's not a talk about rock music. I will not be offended if you sneak out now having discovered that. It's a talk about exception handling in Python, how we think about errors, and I'd like to make this a little interactive. Can I just see everyone who's willing to put your hand up when I ask a question? Yes. All right, and can I now see a show of hands? Who here has ever had something go wrong in a Python program? Yeah, about the same number of people. That is what I expected. So we're going to be talking through a couple of things. We're going to start with talking about why exceptions. That's not the only way we could handle errors in a programming language. I'm going to talk about tracebacks and more or less gush about tracebacks because I love them. We're going to talk about exception chaining, and then we're going to get into the new features. Python 3.11 turned out to be a very good vintage for those who appreciate new features on their exception object, with notes, exception groups, and the except star syntax. And Python 3.11 is now old enough. Can I just see a show of hands? Who here is already using Python 3.11 or a newer version of Python? Wow, a lot of people. Who here is not yet using those? Okay, you've got something to look forward to. And so the starting point conceptually for me is just what should happen when a function fails or doesn't do what we wanted or expected it to? And one simple answer, popular especially in older programming languages, is you just return some error value. You return 0 or -1 or none or a null pointer, or Go has a neat thing where they will usually return tuples. So they'll return an error or the value and that, or you return the actual expected value and then nil if there's no error. And then you can handle this by explicitly checking if the error is not nil, or you can propagate it by checking and then returning the same kind of thing. Or you can do fancy returning an error value. If you've used functional programming languages with result types, or if you've used Rust, this is conceptually pretty much the same thing, except instead of manually unpacking the tuple, Rust will actually give you some nice support with this question mark operator to sort of automatically propagate an error value as a return value in your program. But in Python, not for any sort of deep reason, but just because that's how we do it in Python, we tend to raise an exception. Can I just see a show of hands? Who here has returned an error value from a function when something goes wrong? Yeah, we've mostly done that sometimes. Who here has raised an exception explicitly? Almost everyone. Okay, we're still in the normal part of the talk. And so in Python, it'll look something like this. You can check, you can raise a zero division error. You don't actually have to do anything to propagate it, right? It will just continue on unless you explicitly catch the error. So that makes it a little easier to just start writing a script and make sure that you don't lose track of what errors might have happened because they'll automatically propagate. Or you can catch it with the try except syntax, which I'm going to guess we've pretty much all used. But Python also means we can just leave out some of this logic, right? Python, if you do division, will just raise a zero division error if you try to divide by 0. And you don't need to do much to propagate it automatically. And I think, to me, the big advantage of exceptions over return values is that you automatically get tracebacks. And many people sort of have an aversion to tracebacks because it means that something has gone wrong in your code. But I love tracebacks because they tell me what went wrong in my code. Something's always going to go wrong, and I would rather when I found out about it, it came with a traceback that looked something like this. Does this look familiar to people? Show of hands, yes? Show of hands, no? What are you talking about, Zach? Okay. So we're mostly familiar with tracebacks. They show us the sequence of locations. Each function call has a location. And as of Python, you guessed it, 3.11, tracebacks will also actually highlight which part of the expression raised this error. And so particularly for division, you can actually see here that the division must have been C equals 0 that caused our bug. And so this is a lovely new feature that means I often spend one round less debugging because the traceback now makes it obvious where the error was. And there are a couple of ways that we can raise exceptions explicitly. If we have an exception active and we raise an additional exception, they do what's called chaining. And exception chaining dates back quite a lot further than Python 3.11, so you should all have it by now. If you raise an exception while you're handling another exception, you'll see this line in the middle. During handling of the above exception, another exception occurred. Who here is familiar with this one? Still a lot of people. Okay. Who here has used the from syntax to raise an exception? Fewer people now. The from syntax for exception raising lets you explicitly specify that the exception after the from is the cause of the one before the from. And so this lets you, for example, catch an error raised by a library that you're calling and replace it with an exception type which is specific to your application or domain, but explicitly track where it came from. So it's not just there was an exception while you were handling another error. This is saying, here is my library's error type, and the reason I'm raising it is this other exception. And so that can make things a little more explicit. Alternatively, you can raise from none to hide the previous exception. If you're wrapping it and you don't think the user or the other developer using your code will ever need to know about the other error, you can raise from none, and then it won't print that previous exception. Has anyone here done this? Fair few people. Not that many, though. This can be really helpful because it helps cut down the volume of tracebacks that people have to look through. And if you can do this accurately, you can avoid people having to read long tracebacks which aren't actually informative about what went wrong. If you overuse it, then you've just hidden information that could have helped someone debug things. So it's a real use with care kind of situation. And the magic methods that make this possible are these dunder attributes. The dunder traceback attribute holds the actual traceback object. And if you are doing what my collaborators on open source affectionately call crimes, it's useful, but you don't want to encourage everyone to do them. You can actually modify the traceback attribute. You can remove frames from it, you can assemble your own traceback, you can point anywhere else. And if you're implementing something like the Ginger library for templating, this means you can construct a traceback which doesn't actually point through Python code, but points to whatever else caused the error. So it's contextually pretty useful. The dunder context attribute is actually how we track these other things for exception training. So when you raise an exception while another exception is active, the previously active exception is assigned to the dunder context attribute of the new exception. And if you do raise from, then it's assigned to the dunder cause. And if you do raise from none, then the suppress context attribute is set to the Boolean flag true. If you didn't follow all of that, it is in the documentation, and hopefully you will not need to remember this ever. So that's the reasonable part of the talk, where we cover exception handling things that will likely come up in practice, that you might need to know, that might be a good idea to ever use. But we haven't covered the fun stuff or the new stuff yet. So let's keep going. I mentioned that you can replace tracebacks. This little Monopoly police officer icon is go to jail, which is what your colleagues will say if you overuse this code. So I've annotated my code snippets with little icons to help you track whether it's a good idea to do this most of the time. So exception with traceback lets you basically take a traceback, typically from another exception, and attach it to whichever exception you wish. This can sometimes be useful, but you should be aware that it modifies the exception object in place. It doesn't make a copy for you. And so if overused or used carelessly, this can get you into terrifically confusing situations where you have a big traceback and it's very clear what's going on, except that didn't arise in the normal way, and so the inferences you draw are just wrong, and now you are deeply confused and nothing makes sense. And eventually, you find that someone wrote code like this. A different feature, which I like a little more, also modifies exceptions in place. But the add note method is designed to let you record what was happening when exception went past your code. So I tend to think of this as being something which is most useful for libraries or frameworks, where raising your own custom exception type is not appropriate because you actually don't want to change the exception that the user raised originally. You just want to annotate it and say, this happened while I was doing some particular operation, while I was operating on a particular task, whatever it is. So this was actually my first PEP 678, and I have used it pretty regularly, which is why I proposed the PEP. Use with a little care though, because the notes will just be printed after the exception message in the order that they were added. So you don't want to go overboard or print more information than is really going to be useful. All right. The last sort of major section of this talk is on exception groups. And I'd just love to see a show of hands. Who here has raised an exception group? One person? Two people? Okay, we're into the novel stuff. An exception group is designed to handle the situation where multiple things went wrong kind of concurrently, right? So it's not the case that you had one exception and then that caused another exception. But you had something like, I needed to try 3 different things, so I ran each of those tasks, and I collected the errors, and I needed to raise them. Or I had an asynchronous framework, so I tried doing one thing, and then I started the next coroutine, and it also had an error. And so an exception group has a message, like a normal exception string message, and then it has a list of other exceptions which can themselves be exception groups. So I think of an exception group as being like a tree of exceptions. And this gives us a couple of things. The first, I mentioned, we can just collect them by hand. So there are some things in PyTest, for example, when we're doing fixture teardown, where we'll try to tear down each of the fixtures. If one of those fails, we can't just not tear down the other fixtures, right? It would be bad if we left a database connection open indefinitely, for example. So we have to try each thing in turn. And then at the end, if we got any failures, we'll raise a group that contains each of those failures for you. This is not really intended to be caught by anyone. It's just intended to be a nice way of grouping together things to eventually display the traceback. Who here has been writing async code lately? All right. Who here has had an exception group from their async code? We have a lot of lucky async users here. So again, the NEIO create task group or async.io task groups or trio nurseries, they're all similar concepts, is a context manager which will run a number of tasks conceptually in the background. And if one of those fails, we cancel the other tasks and then we raise the errors. And so if an exception is raised, the task group will always wrap that in an exception group to represent that even if there's only one this time, there could have been concurrent errors. And so we use the exception group to mark that there could have been concurrent errors and to give you some way of handling exceptions when multiple exceptions could have occurred. And I promise we will get onto how to handle exception groups soon. Like right now. The except star syntax is also new in Python 3.11. And so I think part of the reason that we're not really familiar with exception groups yet as a community is because the syntax needs to be supported by all of the versions of any library that wants to use, all of the Python versions supported by any library that wants to use the syntax. Otherwise, you just have this sort of breaking divergence. But Python 3.11 is now mature enough and old enough that many libraries do support it. And so we have except star value error as group, which looks pretty much like except value error as error, right? Except it does something different. The except star syntax can catch either a bare value error, if foo happens to raise a value error, or it can catch the subset of an exception group that matches that type. So if we jump back to this exception group before, we will not catch anything for a value error. But if we ask to catch an OS error, we will get an exception group containing an exception group containing an OS error, and we'll drop the parts that don't match an OS error. Does that make sense? If we asked for except star type error, we would have an exception group that contains a type error and an exception group which contains a type error, but not this last line. And so the thing you need to remember about except star is that the thing that you catch, the thing that that block hands you, will always be an exception group. And so if you have some exception, for example, an HTTP exception with a status code attribute, and you try to do group.statuscode, you'll get an attribute error because exception group does not have a status code attribute. So you can log your exception group. You can use the subgroup method, which does the same thing semantically as except star. It will take the subset of the group that matches the type or the conditional that you have. Or you can do split to divide it into two parts, one that matches and one that doesn't. A lot of the time, though, you're probably, it depends on exactly what your application is doing, but it's relatively rare to need to do much more than log errors, respond in aggregate, or sometimes pull out a single error to raise. And that's a tricky pattern. If you think, okay, I got an exception group containing only value errors, I have seen very much code that does this. It says, okay, get the list of exceptions from the group and raise the first exception. I want to take shouted suggestions from the audience. What's wrong with this code? Do not write this code. What's wrong with this code? The stack trace is bugged. Yeah, all of the stack trace that was attached to the group object is not attached to the leaf. Right? Each intermediate exception group will have the portion of the stack trace that matches when that group was the thing propagating. So doing this will throw away almost all the information about where that error came from, which I don't love. What else is wrong with it? Exception 0 could also be a group. Yes, you thought you were raising a value error, and maybe not. You just don't know, actually. Okay, so what does it take to do this in a clean way? Well, I've seen many people implement a sort of flat exceptions iterator where you walk over the tree and you collect the exceptions. And so that can get you to the point where you're definitely raising a value error, but you've probably still thrown away a bunch of the traceback. So I have a currently open PEP, which is aimed at Python 3.15, which we don't have yet and we won't have till October next year. But I propose basically some new helper methods to give us a list of the leaf exceptions with their complete concatenated tracebacks. Until then, it's going to be a little awkward. Once I finish working out the API, we'll have some nice helper functions in the backport, though. The other problem we're going to have here, which we didn't mention before, I said before that I love tracebacks. I love tracebytes when they're less than like a few 100,000 lines of text. I read pretty quickly. I enjoy a mystery novel as much as anyone else. But I don't love like a mystery novel series where I was the murderer. And that's what this feels like sometimes. Because remember what I said earlier about the context when you raise an exception when there's another exception active? You thought here that you were going to simplify the traceback by pulling out just one element of the group and raising that leaf exception. But when we did that, the Python interpreter helpfully made sure that we didn't lose the context of that exception. And so we now have that leaf exception where its previous context has been replaced by the entire group that we just tried to pull it out of. So we have in fact increased the size of our traceback instead of decreasing it. To fix that, there is a helper method proposed in this PEP, but the essence of it looks something like this. And here again we have the police officer, because while this code is correct, if you write it, your colleagues might be sad. I'm sad when I look at this code, and I wrote it. So what do? We do some magic thing to get one error out of the group with the fixed traceback. Then we record the context currently attached to that error, which might be none. Then we try raising the exception, at which point the interpreter, just before the final loop block, helpfully replaces the original context. And then finally, we go back and re-replace the context with the original context. All make sense? Yeah, I did say it was kind of cursed. But the upside of this is that you can, in fact, destructure exception groups, especially once we get the backport of the helper methods. It's actually pretty straightforward to match with except star, to sometimes use split or subgroup to isolate the parts that you want, to find a leaf exception, to log those. It's only really when you start thinking about the training and the tracebacks, and the tracebacks, that exception groups can get tricky. And so, that's all I have for the core of this talk, folks, and I'm excited to take your questions.
All right, thank you. We have plenty of time, so please line up in front of the microphones if you'd like to ask a question.
So one of the things I learned working in Go is that often when we have concurrency, we have one real exception at the beginning, followed by a whole bunch of other exceptions that are either just cancellation errors or bugs in the handling of cancellation errors. And the flip side of that was people kept asking us for, give me composite exceptions. I want to handle all the exceptions. And they weren't thinking about, oh, I have this O of 1 algorithm that's now O of n because I have O of n tracebacks embedded in the exception. Have we considered other mechanisms to pre-collapse the exception groups to filter out just the first one instead of aggregating this whole big thing and then pruning it back down to something we can print?
Yeah, so we have. One response is, I don't know, man, have you never had a service go down because someone mishandled a cancellation? So for many async frameworks, timeouts are actually handled in terms of cancellations. And that means that canceling a subtree of your work and dealing with that exception as it propagates is something that you'll actually need to get right to build a reliable service in the first place. It can get a little much sometimes, though. That's why we have the split and the subgroup methods to try to easily take subsets. And I do encourage people to think about, like, when do you have an exception crossing some kind of interface layer? And can you subset it then and work out which part is meaningful to propagate and which parts aren't? I've also been discussing a couple of proposals like tagging like a sequence number onto each exception so that we can meaningfully say things like, just give me whichever one of these happened first. Of course, once you have a concurrent or distributed system, happened first is not always well defined. So,
Hello. I was curious, is the new syntax that you're talking about to cut out all that clutter, is that perchance going to be like as group from none?
so that's, let's see, new syntax for this?
Yeah, so instead of just accept value error as group from none, or what is your proposed syntax to cut out the clutter?
So my proposal here is that we will have a group.leafExceptions method, which will give you an iterator over the leaf exceptions or possibly a pair of the leaf exception and the composite traceback. Because if you iterate over the leaf exceptions, which is a reasonable thing to do, and then you don't raise one of those, we would have then messed up the tracebacks of the whole group, which we don't want to do. So that API is still being hashed out, probably at the sprints at PyCon, in fact. And then for the rest of this, we're looking at probably just attaching a context manager to the exception object, which will do this reset for you. So no dedicated syntax, just a method on base exception.
Gotcha. Thank you.
Yeah, thank you so much for the talk. It was very entertaining and informative.
I'm
I was wondering, because one of the metal levels of exceptions are context managers, which is something that you didn't go into much depth. Is there anything on the dunder exit or anything within the building our own context manager that has to change or could be changed as a result of what's happening on Python 3.11? Thank you.
So none of this has to change anything about context managers. You can think about context managers almost entirely in terms of try, except finally. And so it's mostly a question of well, when you're implementing your exit method, you have the option of handling the exception that's propagating past that. And you can do that using split, subgroup, or these other tools.
Thank you.
Great talk. Thank you. When you accept star, say, value error as a group, that group contains only the matching subset, correct?
That's right, plus the sort of branch of exception groups to get to that value error.
What happens to the rest of the exceptions?
So in the case of except each of these blocks will be called exactly once with whatever subset matches.
So the
so
subset that doesn't match will continue to be propagated?
That's right. If there's a subset that doesn't match any of your handlers, it will continue to propagate.
Okay.
In the same way as if you had except type error and actually had a value error, that would continue propagating.
Okay. Awesome. Thank you.
If you raise an exception from within an except star block, then that will be put into a group along with anything else that you raise from other blocks, along with whatever part you didn't handle at all. Yeah. It turns out when you have more exceptions, you have more problems.
All right. Are there any more questions? Nope. All right. Thank you again, Zac Hatfield-Dodds. Please give him a round of applause.
Thank you all. I'll be down here as well if you want to come talk to me.